memorize. They sound worse than they are. They're actually really, really easy. Trig derivatives are one of the easiest lessons. You can end up using them inside of like a product rule. So remember there was that question, you're like, how do I do the one with the sign in it? Trig derivatives. Go. No. Yeah.
I definitely thought it was. I told you.
Okay. Shh. So, when you write, guys, stop. When you put d over dx in front of something, you're saying it's the derivative. So the derivative of sine x. The derivative of sine x is cos x. You're going to have to memorize these. They're not as bad as they seem. The other thing to do as well is any trig ratio that starts with a c, its derivative is negative. And any trig ratio that starts with not a c, its derivative is positive. So it's kind of easy to remember the signs. So sine starts with an s, it's positive. The derivative of cos x equals negative, because it starts with c, sine x. The derivative of tan x equals secant squared x. Once again, it's positive, because tan does not start with a c. Then the derivative of cosecant x equals negative cosecant x cotan x. You will literally have to memorize right away, trust me. Look overwhelming, they're not. D over dx of secant x. Secant starts with an s, so that's going to be positive, the derivative. It's secant x tan x. And then the derivative of cotan x equals negative cosecant squared x. Tomorrow we're going to do implicit differentiation. All right. So, literally, if I just gave you tan x, you tell me it's secant squared x. It's that easy. If I gave you cosecant, you say negative cosecant cotan. So the catch here is example 1. Let's look at a basic one. So we are going to derive the following. Derive means find the derivative of. Derive the following. So what we're going to do is we're going to do some trig. Then you're going to work on some homework. And then we're going to move on to practicing some chain rule questions where I make you find the tangent slope and the equation of the tangent. You have to still be able to do that for every single derivative, right? And the normal. That we do on Friday. So derive the following. A. Y equals tan 4x. If you don't finish your homework today, you chose to not work on it.
Easy? Like one question?
No, not one question. But you'll have time to do the questions. So tan 4x. So you do need to do chain rule with this because you have that 4x in the middle, right? So what we're going to do first is we're going to do the derivative of tan. Yes? So what is the derivative of tan? Right. So the derivative is secant squared x. X just happens to be 4x. And then I have to follow behind with the derivative of the inside because I didn't do the derivative of it. What's the derivative of 4x? 4. So it will often get rewritten as 4 secant squared 4x. That's it. Okay, what happens if I give you a number in front? Y equals negative 3 cos 2x. Okay. When we have that coefficient, remember when you had a number in front of the e to the x? Remember when it was like 2e to the 2x? I told you just leave the number. Because, and the reason why that is if you do this, it'll be product rule, right? So if I did product rule on this, I would get the derivative of cos 2x times the derivative of -3, which is 0. So that half would go away, correct? So that's why when you just have a coefficient number, you don't have to do product rule with it. You can just keep the coefficient and do derivative of what's behind it. So we're going to get y prime equals -3. What's the derivative of cos? Negative sine x. X just happens to be 2x. And then what do I have to do? Derivative of the 2x, which is 2. And then I take all my numbers in front. This would be like -1. So I get -3 times -1 times 2. And what do I get? 6 sine 2x. Negative and a negative. Thanks for the positive reinforcement, Ashton. All right. What if I give you this? F of x equals secant 3x. Wait. What's the derivative of secant? Secant x tan x. So I'm going to get secant 3x tan 3x. Then I get some people putting a 9 behind because they go 3 and 3. But there wasn't two 3x's, correct? There's only two 3x's because the derivative of that is secant tan. So what do we actually multiply behind it with? Just a 3 because there was only one up here. And then we write it in the front. Okay, what happens if I do this? G of x equals sine squared 3x squared plus 6x. So, remember when you get a squared in the middle, if you went to go type that into your calculator in 30-1, the moment you press sine, a bracket opens up, right? There's no ability to be able to put that 2 in there. A bracket opens up right away. So we would have to go sine 3x squared plus 6x, yeah? All what? Squared. So if you ever get the squared in the middle, your very first step is to rewrite it as sine 3x squared plus 6x all squared. So what do I have to do first? This actually isn't an instant trig. This is actually an instant what? Chain rule. So we practiced all those chain rules with the bingo. This is a chain rule. So we have to go g prime of x equals 2, rewrite it, all to the 1. Do I need to write the 1? No, but I'm going to just prove a point. Now what have I not done yet? The derivative of the trig. So what's the derivative of sine? Cos 3x squared plus 6x. Then what have I not done? The derivative of the inside. 6x plus 6. Can I do anything with that 6x plus 6? You take the 6 out and bring it to the front. So we'll get g prime of x equals 12, x plus 1, sine 3x squared plus 6x, bless you, cos 3x squared plus 6. So our first rule here was to chain, then to trig, then to chain again. Right? Okay, this is the one that I want you guys to try on your own, and then we're going to do another type that you could see. Because the hardest part of doing derivatives is see and then know what to do, right? If I say, oh, you have chain rule first, you're like, oh, that's not too bad. But you have to be able to see and know what to do. So I want you guys to try this one on your own. I don't want squared, I want secant. Okay, try that one. So, the first thing we want to do is rewrite it so that it is cosecant 6x plus 1. Quiet, please. Squared. And by squared, I mean cubed. I don't know why I said squared. So, the first way we get the derivative is we drop the 3 in front, rewrite it, and then it is squared. Okay? Then we work our way to the inside. What's the derivative of cosecant? Negative cosecant x cotan x and then what do we still have to do? 6. Yeah, just a 6. So, I want to draw your attention to two things. So the 6 here gets multiplied by the -1 here, like all the leading coefficients, right? Gets multiplied by the 3. So what do we end up in the front with? -18. Okay? The other thing that is fine the way it is, but your answer key will not be this way. We didn't have to do it on the last one because it knocked down to 1. But this one knocks down to a 2, correct? They will re-put that back in the middle. So they will rewrite this as cosecant squared 6x plus 1 cosecant 6x plus 1 and then cotan 6x plus 1. Do you notice anything we could possibly do? Yeah? Yeah, put it back in there. Is there anything we could do still? Pardon? Can't take one out, there's no plus signs. Nothing to take out. Could you put them together?
No.
This is cos squared 6x plus 1, guys, is the same as, cosecant squared 6x plus 1 is the same as cosecant 6x plus 1 times cosecant 6x plus 1. And what's beside it? A cosecant 6x plus 1. So can we not just put them together and make 3 of them?
Probably.
Yeah. Because it's multiplied. Okay, the next one I want to talk about, I'm going to call it F, little I, and little sub I. The reason why is that when given these questions, you guys feel like these are the same question. They are not. They are done differently. Okay? So I'm going to show you the first one. Y equals sine x tan x. The second one is y equals sine tan x. What is the difference? so the first one, sin x and tan x are multiplied. There's two x values, correct? So how are we going to do this one?
Do whatever you want. Close sheet rule.
You're going to do product rule. You have two things multiplied, correct? Okay, what is this one? I heard Kelson say he was right. Tan x is a function of sin x. When that happens, that's chain rule, right? You have something embedded in the sin x. Before I gave you sin x, and then I gave you like sin 3x or something, correct? So then you did cos 3x times 3, yeah? This one you'll do cos tan x times the derivative of tan x, correct? So try these two out. So, okay, stop. F, G, F prime is cos x, G prime is secant squared x. All right, so y prime is G, F prime plus F, G prime. Now sometimes for this one, they might make it simpler. What they could do is they could say, oh, tan is sin x over cos x. And they cross the cos x's off, and then they take a sin x out, and they're left with 1 plus secant squared x. And 1 plus secant squared x, I believe, is 10. 1 plus tan secant. They could replace the secant with 1 plus tan squared and then get tan squared plus 2. So sometimes you just have to keep going to match their answer key, is all, if it's in the textbook. And like I said, I'll let you have the 30-1 formula sheet, so you'll be fine if that happens. Okay, this one is a composition. And when it's a composition, you know, like f of g of x and g of f of x and 30-1, we learned about that. Composition of functions. It's for chain rule. So y prime, the derivative of sin x is cos x. X just happens to be tan x. And then what's the derivative of tan x? Secant squared x. That's it. Can't get any better than that. This is one full term. So is this, and they're multiplied together. Because the cos can't ever, even if this had a cos in it, you can't actually take a cos out, because it's a cos tan x, right? It's not a cos theta. So the only way you can take a cos tan x out is if you have a cos tan x. Plus chain. Okay? The last thing we can do is if I give you y equals secant x cos x. That's a lie. I don't want the same thing. Sin x. Secant x sin x. Give me the derivatives of that. So f is secant, g is sine. There's a multiplication because they both have an x. F prime is secant x tan x. G prime is cos x. Y prime equals G F prime plus G F prime plus F G prime. I want m tangent at pi over 6 and root 3 over 3. And you're nice, I'm nice enough to give you the root 3 over 3. Can we reduce this?
Yeah.
To make our life better? What could we do?
Secant x out. And then take another x out.
That doesn't make it better. So let's change secant x to what? 1 over cos? What's tan x? Sine x over cos x. What is this one? 1 over cos? Guys, that cancels to become 1. This becomes sine squared x. Shh. Guys, no. Sine squared x over cos squared x plus 1. What is sine squared x over cos squared x? Someone said it, I think. Tan squared x plus 1. Guys, what's tan squared x plus 1?
Sine.
Nope. Secant squared x plus u. So your m tangent equals secant squared pi over 6. So you need to get cos of pi over 6 and flip it and then square it, right? Pi over 6 is the same as 30 degrees. What is cos at 30 degrees? Try the opposite. Root 3 over 2. So I'm going to get, not root 3 over 2, what am I going to get? That would be cos. 2 over root 3. And then what do I have to do to it?
Rationalize that.
Just square it. When I square it, doesn't it rationalize it? This was squared, guys. So I need secant of pi over 6 squared. So this is going to be 4 over 3. Right? Then we'll get y minus root 3 over 3 equals 4 over 3 x minus pi over 6. 30-1 doesn't go away, guys. Okay, I'm going to give you this.